Hi everyone, I am going to continue chapter 10.3, which is inferences for two populations means using independent samples. This gonna be standard deviations not assumed equal, which mean unknown. But if you remember, last time we did standard deviations assumed equal but also unknown. So let's go through this. Uh, Last time we discussed a standardized version of x1 bar minus x2 bar, which is x1 bar minus x2 bar minus mu1 minus mu2 divided by square root of sigma 1 square n1 is square divided by n1 plus sigma 2 square divided by n2. Here mu1 is population mean, population 1 mean. I will write here population 1 mean, and mu 2 is second population's mean. So population second population's mean. Okay, sigma 1 and sigma 2 are population standard deviation for population 1 and population 2 respectively, and also n1 and n2 are population size for population 1 and population 2 respectively. So they have mentioned it here, but the problem is here sigma 1 and sigma 2 both are unknown, we do not know them, and also they are different. Last time we talked about they are similar but unknown, but now here they are unknown as well as they are different. So we have to use, to overcome this problem, we have to use sample standard deviations, which mean S1 and S2 with respect to sample 1 and sample 2. Okay, so if we use standard sample standard deviations S1 and S2, we can rewrite the standardized version of x1 bar here bar, x1 bar and x2 bar, like x1 bar minus x2 bar minus mu1 minus mu2 divided by S1 is square root S1 is square divided by n1 plus S2 is square divided by n2. We replace our sigmas, replace sigma 2 squared by S2 squared, and replace sigma 1 squared by using S1 squared. So we have a t distribution with degree of freedom. This time we have to calculate. So how we calculate this degree of freedom? By using this giant formula. So you can plug the values to this formula and get the degree of freedom, but remember that always we rounded down to nearest integer. For an example, if let us say degree of freedom equals 84, let us say for an example 84.8. So what we have to do is we have to round this down, which mean we have to consider it is 84, okay, something like that. Okay, let me introduce our alternative and null hypothesis. Same as previous cases, our null hypothesis is h naught mu 1 equals mu 2. Always we consider equal for null hypothesis. Then alternative hypothesis can be mu 1 not equal mu 2, or mu 1 greater than mu 2, or mu 1 less than mu 2. These are alternative hypotheses, but at a time we have only one alternative hypothesis from these possibilities. Okay. Test statistic. So since our h naught, which mean mu 1 equals mu 2, our mu 1 minus mu 2 term goes to 0. So, that is why here we do not have mu 1 minus mu 2 term. So, now our test statistic is x 1 bar minus x 2 bar divided by square root of x 1 squared divided by n 1 plus s 2 squared divided by n 2. So, we can refer the t table, but before we refer the t table we need the degree of freedom. So, how we calculate the degree of freedom? Plug the values to this formula. Use your graphing calculators to calculate this degree of freedom and then round down its value to nearest integer. I will show you how we do this few slides later. Critical value approach. You know that there are two ways to solve this inference problems using critical value approach and p value approach. So, first critical value approach. First we have to state the null hypothesis and alternative hypothesis, decide the significant level alpha, compute our test statistic simple t, which mean this one using this formula, and find the critical value using t table. This time you need to figure it out what is the degree of freedom before you go to the t table. Then if it is left tail test, you can find negative t alpha, you can find the t alpha and put a negative sign, which mean we reject if negative t alpha greater than t, we reject if negative t alpha greater than t, something like this, t is in rejection area. Next one is right tail test. If it is a right tail test, then you have to find just t alpha. We reject our null hypothesis if t test statistic value greater than table value t alpha, which means t within the rejection region. The other case is two tail test. You have to find negative t alpha over 2 and positive t alpha over 2. We reject if we reject our null hypothesis if t greater than t alpha over 2 or t less than negative t alpha over 2, like this within this rejection region. Clear? Next one is p value approach. Same previous steps are very similar. State the null hypothesis and alternative hypothesis. Decide the significant level alpha. Alpha is given, you have to get the significant level, then compute the test statistic using the same formula. Next you have to find the p value using t table. Okay. So, in this case same as the previous one, we have three different scenarios: left tail test, right tail test and two tail test. So, in left tail test we have to find the p value. If our p value within the rejection region, then we have to reject it. Right tail test, find the p value. If p value is in the rejection region like this, then reject test node. If it is a two tail test, our p value within these two rejection regions, then we have to reject the null hypothesis. For two tail test, we can find the p value by multiplying your table value 2. Okay, your table value multiplied by 2, it gives you the p value. Reject null hypothesis if p value less than your significant level alpha, which means within this rejection region. Okay, let's see this. Let's check this example. Several neurosurgeons wanted to determine whether a dynamic system reduced the operative time to a static system. Okay, dynamic and static systems at 5% significant level. Do the data provide sufficient evidence to conclude that the mean operative time, so mean operative time is less with the dynamic system than with the static system. assume both, this is important, assume both populations are normally distributed. Okay, since populations are normally distributed, no problem with that, we can assume x1 and x2 they are normally distributed. So I have considered here my x1 is the dynamic group and my x2 is the static group. So n1 they have given this information, n1 equal 14, which means first sample size, and second sample size is 6, n2 equals 6, x1 bar given, x2 bar given, s1 first sample standard deviation is given, second sample standard deviation is given. So let us use the critical value approach. Step 1, you mention what is your null hypothesis and alternative hypothesis, but before that you have to mention what is the x1 x2 mu1 mu2. x1 x2 I have mentioned the last slide. So I suppose that mu1 equals to population mean operative time of dynamic group and mu2 population mean operative time for static group. So now my my null hypothesis is mu1 equals to mu2. Then my null alternative hypothesis is going to be, it should be what they have mentioned. So they need to conclude that mean operative time is less with the dynamic. So mean operative time less. So what should be the alternative hypothesis? Mean operative time less than the static case. So which means our alternative hypothesis is going to be mu1 less than mu2. Okay. So your alternative hypothesis you have to pick according to what they have asked. Okay. But your null hypothesis always equals mu1 equals mu2. Okay. Step 2, what is your alpha? I think alpha is 5%. So 5% mean, when you convert it to decimal, it is 0.05. Okay. So next step is the test statistic. So t using this by plugging values to this formula you can figure it out what is the t. Since this is since this S1 and S2 they have given, you can simply plug those values and you can find this t, but you have to find the degree of freedom as well. So again plug these values, because you know what is S1, S2, N1, N2, you know all these values. Simply plug those values and figure it out what is the degree of freedom. Here degree of freedom is 17 and t is negative 2.86. Okay. So in this critical value approach you have to let me check these values 17. Okay. So t, you have to go to the table and find t alpha is 0.05. You see they have rounded down, degree of freedom rounded down, so 17. So you have to find this from your t table, 0.05 and degree of freedom is 17. So you will find this value is negative 1.740. Why negative? Because your alternative hypothesis mu1 less than mu2, this is left tail test. Okay. So they have mentioned here left tailed. Okay, what is step 5? So you know what is this t value, you know what is calculated t value, calculated test statistic value. This is your test statistic value and this is your table value. So if you see these two values, you will see that your test statistic value, I will write test stat test stat value is less than your t 0.05 comma 17 value, which means your table value. So, what you have to do? We have to reject our H naught. So, we can write at 5% significant level, we have enough evidence to say that on average operative time for dynamic group is less than the static group. Why we write like this? Because we reject our H naught. So, we have enough evidence to say, we have enough evidence to support that what they have asked. Okay. Okay. Uh, so, I am not going to solve this, yes, using p-value approach. It is very similar. We have done this. You can use p-value approach or critical value approach, does not matter, you can get the same answer. So, last part is confidence interval. Find the confidence interval for population difference. Independent samples throughout this chapter we considered independent samples. Standard deviations are not equal. So, confidence interval 100% 1 minus alpha percent confidence interval you can find using this formula. We simply got this by multiplying both sides in our previous test statistic formula. So, you do not have to worry about that, you can use this formula to find out 100% 1 minus alpha percent confidence interval. But in this case standard deviations, which mean S1 and S2, though we do not know and they are not we do not know, they are not equal. Actually S1 and S2 we know, but we do not know sigma 1 and sigma 1 and sigma 2 we do not know. That is why we use S1 and S2. So, all terms you can find out what is x1 bar, x2 bar. So, you can find this T alpha over 2, S1, S2 given, N1, N2 given. So, simply you can find this value. Since this is plus or minus here, you will be having two values, lower value, lower bound and upper bound, lower value and upper value, something like that. Okay. So, find 90% confidence interval for mean time difference dynamic static group for above example. Okay, 90% confidence interval, which mean alpha equal to 0.1, alpha gonna be this is gonna be 1 minus so this is going to be 10%, which mean alpha is 0.1. So, they have mentioned here, but we need alpha over 2. So, alpha over 2 is 0.05. Okay. What is the degree of freedom? 17. So, you can go to the table and find T 0.05 comma 17, it is 1.740. Then you can plug that value to this formula. You know what is x1 bar, x2 bar, all other variables. So, you can simply plug these values and find this interval. See, in this interval there are two values, lower bound and upper bound. See, there are two values because it is an interval. Okay. So, this is the interval 90% confidence interval. This is the 90% confidence interval for mean time difference for dynamic and static group for above example. Here 90% we get 1 minus alpha. Okay. So, 90% confidence interval for mean time difference for dynamic and static group is what you found here. Okay. Okay, this is the end of this section. So, I hope it is clear for you. So, please go through this once again and thank you for watching this video.